All right, greetings everyone. Welcome to the part of the video now for section 2.5. Just a couple more things to go over in regards to absolute value functions. Okay. So now we're going to talk about solving inequalities, absolute value inequalities using graphs. And actually, we're going to look at two different techniques for solving these. We're going to look at first using a graph, and then a more algebraic technique. And first of all, point out what we have here. So we're asked to solve the inequality 3 times absolute value of x minus 1 plus 1 is greater than 7. Okay? And notice what this means is we need to find values of x, that we could plug in here that'll make this whole thing here on the left, this 3 times absolute value of x minus 1 plus 1, greater than 7. Okay? And so one way to do this is using our graphing calculators. So what I'm going to do here is I need to write this down for myself. Okay, so if you go to your graphing calculator, and it doesn't matter what type of calculator you're using here, should be able to do a similar thing to what I'm about to do. We're going to go to our y equals, because we're going to graph. And we're going to start by graphing the expression or the function that was on the left-hand side there. Okay, so that 3 times the absolute value of x minus 1 plus 1. And we can do that in our calculator. So if you hit 3, and then if we press the math button, which is below our alpha button here, okay, so we hit that. If you go over to NUM, oh boy, okay, hold on. There we go. Notice the first thing we have here is ABS, and ABS means absolute value. So you can either press 1 or press enter on that. If you have a newer calculator like I do, it'll put actual absolute value bars there. Otherwise, it may just say ABS with a parenthesis on your calculator. You can now put in the x minus 1 there. So I've got 3 times the absolute value of x minus 1. If your calculator just says ABS, you'll need to close your parenthesis after that. Then we'll press plus 1 there. Okay. And then we also want to know where this is greater than 7, where this function or expression is, right? So on the second line here, I'm going to put 7. And notice that that's going to be a red line, and the top one will be a blue one. So hit graph now. So see the blue one there, there's our absolute value function. And then there's the line f of x equals 7. And remember that our goal here was to find where 3 times the absolute value of x minus 1 plus 1 was greater than 7. So where's that going to be here in this picture? You're right, it's going to be values above where 7 is, right? So it'd be values like up here or up here. And so what are the values of x where that happens? Well, notice there's a range, first of all, right? Because the graph goes on forever this way and this way. So it's kind of like starting at those intersection points right there and going to the right and the left. So starting like right here and maybe right here. And it looks like there, that one's at x equals -1. And right here, this one's at x equals 3, it looks like. And notice at those values, it's equal to 7, which is not what we're looking for. We're looking for where it's greater than 7. So it looks like for everything below -1 and everything above 3, that would be our solution set. So it actually looks like we get some interval answers here, right? And so to say everything less than -1, we could say -infinity, comma, -1 parenthesis, again, because -1's not included. That's where it's equal to 7. We'd also have parenthesis 3, comma, infinity, and again, parenthesis on the 3 because it's not included, because that's where it equals 7. If we take the union of those two things, then that looks like that would be our answers there, right? So those are the values of x that'll make that greater than 7. And if you take any number in any of those intervals, say like -10, -5, 5, 100, plug them in, you should see that they give you values bigger than +7. Okay. All right, well, you probably saw that that's kind of an inexact science, right? Not super satisfying. So there's got to be a way to do this a little bit more algebraic, right? And the answer is yes. And so let's look at that. So here we're told for what values of x is f of x greater than 0 if f of x equals absolute value of x minus 3 minus 5. And basically, right, what we're looking for here, since this is what f of x is, we could put that in here, and we're trying to figure out where is the absolute value of x minus 3 minus 5 greater than 0. Okay? There's going to be a few steps to this. The first thing we're going to do, and actually I should also say, I'm going to show one way to do it. For those of you who've maybe learned about how to solve inequalities before involving absolute values, you might know a different way to do this, but I'm going to use something called a sign chart, which is actually going to be a useful technique to learn because we use it again later on in calculus. So it's a good one to learn here. So I'm going to start by solving for when the absolute value of x minus 3 minus 5 is equal to 0. So even though we're trying to find greater than, I'm going to solve for where it's equal to. So we can do that by adding 5 here. So we would have absolute value of x minus 3 equals 5. Set up our two equations. So x minus 3 equals positive 5. X minus 3 equals negative 5. Add 3 to both sides on each of them. We'd get x equals 8 and x equals negative 2. So those are the values where the function is equal to 0. Okay. Now, this is where things might get a little bit different, something you may or may not have done before. We're going to set up what's called a sign chart here. So when I do that, what that looks like is I'm going to draw a number line here. I'm going to put my two places where the function equals 0 in order on there. So I'm going to have negative 2 here and 8 here. And at each of those values, I know that the function is equal to 0. And what I want to know is what happens left, in between, and to the right of those. And here is how I do that. So I'm going to first check a value, or pick a value, that is less than negative 2. So I'm going to work with, say, x equals negative 3. I'm going to plug that in to my function up there. So the absolute value of x minus 3 minus 5, so that'll be negative 3 minus 5. Absolute value there, so that'd be absolute value of negative 6. 5, absolute value of negative 6 is 6 minus 5, gives us a 1. And notice there that gives a positive 1, right? At x equals negative 3. So what that tells us, and this is kind of an amazing fact, but even though we only tested one point to the left of negative 2, we got a positive value. And that actually tells us that for all values less than negative 2, this function, f of x equals absolute value of x minus 3 minus 5, gives off positive values. And you could check other ones. You could check negative 4, you could check negative 3.5, you could check negative 100. Plug any of those in, you'll see they all come out to be positive. Kind of cool, right? And you may think about why that is, but I'm not going to talk about that right this second. Next, what we're going to do is pick a value between negative 2 and 8. And luckily, it's a really nice value that's in between the two of those, and that would be 0. So we'll plug in 0 here. So I have absolute value of 0 minus 3 minus 5 becomes absolute value of negative 3 minus 5, which becomes 3 minus 5 equals negative 2. So notice in this case, we got a negative value. And so what that tells us is that for all numbers between negative 2 and negative 8, or sorry, negative 2 and positive 8, that the function f of x there gives negative values. And again, you could, trust me, you could check other values. So you could check negative 1, you could check 7, you could check 0.5, and you should see in each case you'll get a negative value. And then finally, we'll check a value bigger than 8, so we'll do x equals 9. So we'll plug that in, we'll have absolute value of 9 minus 3 minus 5, which will be absolute value of 6 minus 5, which is 6 minus 5, which is 1. In this case, a positive 1, right? So what we see then is that for all values bigger than 8, the function gives positive values. Okay, and so now we've got our sign chart set up that tells us that for this function f of x, for all values less than -2, the function is positive. At -2, the function is equal to 0. Between -2 and 8, it's negative. At 8, it's equal to 0. And then for values of x bigger than 8, the function is positive. So what does that tell us then about how to answer or solve this inequality we've been given, that f of x is greater than 0? Well, if it's greater than 0, it's going to be all the values where the function was positive, right? Because that's what's bigger than 0. And that looks like it's all values below -2 and all values bigger than 8. So if we write this as interval notation, it looks like the answer would be -infinity to -2, not including -2. That's why the parentheses there, because the function's equal to 0 there, not greater than 0. We can union that with the other set, which would be 8 to infinity, right? And again, not including the 8 because there the function is equal to 0. And there would be our answer. Okay? Great, that's it for now. Thank you for watching.